Okay, this is the last one in the series on Newton's laws. Okay, and what we've got is we've got a pneumatic cylinder, and it can move in and out like this. Okay, so there might be something attached on this that needs to move in or out or something like that. We don't really know what its purpose is, but there it is nonetheless. Okay, so this thing's going to be moving in and out, and it moves in and out according to this equation with the cosine. Okay, now we're being asked to find out what the force is. Okay, so what I want to do is I want to write stuff down, so I got to make my sketch. Now I'm just going to kind of go off of what I've got here. Although, well, let me show you what I would do on my own, as I would do if I didn't have a drawing. I'd go something like this, and I'd say, okay, it's moving in and out. And I know that the thing that's moving has a mass of 0.35 kilograms. Okay, just like that. And I know that it's moving according to the equation 0.25 cosine 0.3 t. Okay, so then I've got everything moved on there. By the way, that's going to be meters, just like that. Okay, so it's asking about force, and force is going to be ma. So the key to pulling this off is going to figure out what is the value for a. Okay, so let's start with our original equation here. So x is 0.25 cosine 0.3 t. Okay, and then let's start taking derivatives. So the first derivative gets us a 0.25 onto 0.3. Derivative of cosine is sine 0.3 t. Okay, and now remember, when we do the derivative of the cosine, the chain rule says that that term comes out front, and that's where this term comes from there. Okay, let's take one more derivative to get to the acceleration. So now I'm going to have 0.25, 0.3. I got to put another 0.3 on there. We're back to a cosine, 0.3 t. Okay, now I did forget a minus sign in here. So there's a minus, and that carries through down to here as well. Okay, when I calculate all of this stuff out here in front of my cosine, what I'm going to end up getting is 0.0225 cosine 0.3 t, and it's negative. Okay. So to calculate our force, what we'll do then is we'll just say that this is ma. And so my mass is 0.35. That's kilograms. And my acceleration is negative 0.0225 cosine of 0.3 t. And that's meters per second squared. Just like that. Okay. Let's talk about units. So see, I've got cosine or kilograms, and I've got meters per second squared. So that's newtons, which is my unit for force. So that works out pretty good. And then what I actually kind of wrote this a little bit wrong. For my t, all right, I would go ahead and put in 1.5 seconds there, just like that. Okay. Then I'm going to calculate all of that out, okay? And what I'm going to get is negative 0.00709 newtons. Okay, it's pretty small. However, I've got 0.3 times 0.02. So I expect to get something small. So that sort of makes sense. Now, one of the things you need to watch out for is whenever we're using cosine in this way or sine in that way, the argument inside there when we plug in our units needs to be radians, okay? So you need to do that calculation, and if you don't get the same number I got, then you didn't do it in radians, okay? Just like that. All right. Anyway, there you go. So use degrees when you're dealing with a specific angle, 20-degree incline, that sort of thing. But if we're describing motion this way, especially oscillatory motion, use radians. Okay, so switch your calculator back and forth, and don't forget to change it up after you do that. Or don't forget to put it back. Anyway, just pay attention to that. That's what I'm trying to say.